Now, if I can introduce Kevin Williams for the ESTCP Project of the Year Award. Meg and Allison was a close-knit team, and you know, the numbers are not big. It was 2 people that were involved. Others, of course, were involved. In Kevin's case, he brings a team to the program. He's working in the field. He's working in the ocean. He's on board ship, and the data content for the acoustic-based system that he's using is both massive in amounts and deep in complexity. So it takes a team of people, represented by Kevin, who, again, congratulations for your efforts, Kevin, to both you and the team. I'll let you take over.
Great, Dave. I want to reiterate what Dave said here, right? When you do these kind of things, it requires not only a lot of talent at an individual institution, but it requires that you reach over and work with other institutions, and it's the key to success. And if you take nothing else away from this today, I will tell you that the ability to work with Edge Tech in an engineering sense on a day-by-day basis, and for them to give us feedback was essential on the sensor part, and from the standpoint of actually going out and fielding the effort and having something to run it over. The efforts at PNL up in Squim Bay in Washington were key to that piece of the effort. So I'm not going to be able to appropriately kind of explain how all those details work, but I can tell you that this doesn't succeed without everybody working together and bringing their expertise to the table. So what I want to explain in just a few minutes is this fielding of what we call a multi-sensor Towbody. It's an acoustic system that is aimed at detecting, classifying, and geolocating underwater munitions. So our goal, starting a couple of years ago, was to design it, build it, test it, demonstrate it, and its ability to detect, classify, and geolocate military munitions in underwater environments, and in particular to be able to look beneath the sediment and find stuff that was buried below sand or mud or any other media that you might think of. During this year, really, it was a culmination of a lot of things that had happened in the last couple of years, and that was the ability to go over and operate the Towbody over a prototype system in Squim Bay and demonstrate that certainly we can detect. We believe we can certainly geolocate to less than 2 meters, stuff on the bottom, and then start to produce classification data products. Next slide. So let me go with the technical approach first, and then I'll show you a couple of slides that are results to date. So as I mentioned, Edge Tech's important in this effort. We use a system they call the EBOS, which is a sub-bottom imaging sonar system that's then modified to specs that we wanted. One of the particular things was having 2 sources instead of 1. What's big on certainly on the processing side, and it is really the brainchild of Tim Marston, is the ability to do the real-time processing both in the real aperture, which is a cross track, and in the long aperture, synthetic aperture part of the effort. Do that in real time has been a major advancement in the processing side. Also, Tim's been able to take the data that I'll show you and been able to get it to the point where we believe we can start looking at data products for classification. So there are 3 pieces to our approach going forward, and one is the prototype operation this year. Then we hope to have score demonstrations 2001 and commercialization hopefully in that 2021 and commercialization in 2022, 2023. Next slide. So we did two things over this year. One of them was we took the Towbody out as we were testing the INS, and we flew it over a plane wreck, which is shown on the top right. It actually, one of the things it did was show just how good the 3D imaging could be from this system, on this case, object sitting on the bottom. And then we went to SQUIM, which is in the lower right, and we ran over a test bed put out by PNNL. It's a prototype of what might be an eventual full demonstration test bed. We spent 4 days going over that site. We ran survey lines. If you look at it, there was two pieces to that site. On the top left of that site, at the bottom, you can see a blue box and then a black line. The black line is the calibration line or IBS line, and the blue box is where there was a blind test set of targets. Next slide. So that's blown up a little bit on the top right. You see the two sites there. There were 30 objects total, 15 on the calibration line and 15 that were in the blind test area. What we're able to do, and you can see that in the bottom right, is all the detections that we made in post-processing that could be done within 24 to 48 hours of the effort. And it really shows in detail that you can pick up the targets. And as you run it over targets in different angles, you actually get different views, and multiple hits help you determine whether it's real target or whether it's something else, because you get to look at the target from different angles. From the geolocation standpoint, from the detection standpoint, we feel like we've got a ways to go, but certainly we've seen most of the targets, we've detected them, both the blind and the calibration site. In the geolocation site, this is something Tim really worked hard on. And at least in combining the three different survey lines, we could get very small errors in an RMS sense between survey lines, though the bias error seems to be less than a meter, but that's still TBD probably a little bit, but we feel good about that. Next slide. So in the end, you know, after taking all the survey efforts and looking at what we have to this point, the top right shows black diamonds, which are our confirmed belief that we have targets there that are man-made, and we have them geolocated. From the classification standpoint, the bottom right quadrant there shows both what shows up in real time, which is the cross-track and the SAF process data shown in 2D projections, either looking down or looking to the side. The side view shows that we definitely can see down to a couple meters. We've seen deeper than that, depending on the sediment that we're dealing with. And then far right bottom is just a couple of the data products you can pull out of the data that's available. Next slide. So again, the picture there is an indication of some of the team, not all of it certainly, but just an indication of how many people it takes to make something like this work, and everybody needing to do their job at the highest level to make us successful. We think we've demonstrated it at a research level. We still need to work a little on the INS system. That's what we're doing right now. We need better detection algorithms from people like David Williams and others, and we certainly want to work on those classification algorithms, and we think we have the data to move that along, again, with the help of others that are part of SERDP and ESTCP. And with that, I'll end and open it back up to David.
Thanks, Kevin.